This is Shakil Ahmed. In this tutorial, we will discuss about ridge regression. Ridge regression is a linear regression technique that helps in preventing overfitting by adding a penalty term to the sum of squared uh, while minimizing the residual sum of square. We add a penalty term with square root of the coefficient. These penalty terms basically shrink the coefficients towards zero, which can be particularly useful when dealing with multicollinearity, having a high correlation between independent variables. The strength of penalty is controlled by a hyperparameter called lambda. Sometimes I have just mentioned as alpha, as in Python, we use the term alpha. A large alpha imposes a stronger penalty leading to smaller coefficient. So basically, the coefficient alpha makes a trade-off between bias and variance. A larger value of lambda will lead to a smaller variance, but with a higher bias, and vice versa. So we need to make a trade-off between bias and variance while setting an appropriate value of alpha. So we start with the strokes prediction data set. The dependent variable I will take here as the average glucose level, and we will select different predictors available in this data set. So we will just upload the strokes data. Okay, upload from here. This stroke data, and then import pandas as PD to read the CSV, and the PD dot read CSV is used for reading CSV files from uh, Google Drive. It is already uploaded on Google Drive, and then data frame head is used to see first few observations. So let's say we have these observations, these variables with different number of observations. You can check the summary statistics and the distribution of the variables, but we are going to apply the ridge regression for predicting the average glucose level, taking other variables as the predictors. So we need pandas. We have already imported, don't need to import again, and NumPy, and then SNS for plot, and PyPlot for as well as for plotting. And then from model selection, we need train test split command library to uh, separate the data into training and testing. And then from SK linear models, we import ridge regression, ridge. And then we also need to standardize the variables. So we need standard scalar and one hot encoder. One hot encoder is used basically to categorize multiple categorical variables into binary with 0, 1 for specific categories. For example, if a variable has three categories, it will make three uh, binary variables with 1, 0, 1 presence of the category and 0 for absence of the category. So we also import the column transfer to transfer the columns, and the pipeline package, and then mean squared error and R square as performance measures. So we now just drop the variable column ID. This is not required, and then we check for the missing values in other variables. So the BMI has 201 missing values. So we will impute them using their mean of the available values. So just use data frame and then select this column and then fill an A with mean of the BMI and in place is equal to. So the missing values in the BMI column will be replaced by mean of the remaining values. This is just simple imputation. And then define features and targets. We will select all other variables as target, excluding the average glucose level. And here we have two variables, the average glucose level and average glucose level 2. So if you want, you can also discard this. Basically, these two variables are same. And otherwise, this variable will predict the average glucose level almost perfectly. So if you want to exclude, then you can exclude that as well. Average glucose and average glucose 2, I think. You can just copy this. The name should be exactly as same as you have mentioned here. I think the name is correct. We have missed the commas. Now we have excluded both average glucose levels from the predictor set, and the average glucose level is the response variable. And then we just categorize the columns as the categorical and numerical columns using the object type. Object type means these are categoricals, and integers and float 64 are numerical columns. And then we are converting the numerical columns to the uh, binary one hot encoder using one hot encoder command. Drop first handle unknown as ignore. It will drop the first category, and for other categories it will create the binary dummy variables. So let's see. We should run these packages first, and then we can run this. So uh, you can see how many variables you have. Get feature names out. Yeah, first we need to fit this, and then it will be. So we have just defined one hot encoder, and then preprocessor column transformer when it's numeric transformer, and when it is categorical transformer for numerical columns and for uh, categorical columns. So for numerical columns, it will be converted to standardized scale, and for categorical columns, it will be converted to standardized scale. And then a rich model pipeline, and it will start with the uh, start working with the ridge regression model. It's just work with a pipeline and then pre-process the data and then regressors and preprocessor. This is preprocessor and regressor rich. This is the ridge regression model command with alpha is equal to 1. We are setting alpha as just guess value. So is just run it and then we separate the data and then we will run the uh, rich model. This is the model we have defined here and dot fit and then the input x train and y train and then we can predict the uh, test set values of the y from test set using x test, and we can just print the values so you can see the predicted glucose level for the individuals in test set. And then you can find the mean square error using the mean square error command and using the y test and y predict and the root mean square error using the np square root, and this is from numpy package, and then r square. This is also we have imported from the performance measures and y test and y predict. So we got the mean square error that is now 1774 and root mean square error is this and r square is this. So previously it was around 0.00 something, as I had included the average glucose level 2 in model as a predictor. So now I have excluded, so the performance of model is very poor, around 0.07 r square, and mean square is very high. And then we can just display the predicted values versus the actual average glucose level on a scatter plot and uh, just run a trend line. So what we can do, we can just make a scatter plot and then run a line with x is equal to y. X is y test and y is y predicted. So we are just making a scatter plot for y test versus y predicted values, and then title lab, and then we are just running a straight line, 45-degree straight line with PLT plot with the minimum value and the maximum, and y test minimum value and the maximum value. So we are just basically attaching the minimum point with the maximum point through a straight line. So now we can see, now this is the variable plots and this is the line, and we can see the residual is all has low correlation. If the points are plot closely plotted on this straight line, then we can say that the model is better fit. The model has a better fit. So that's all about the prediction. And then one thing we can do, we can tune the parameter lambda or alpha, as we have just used a guess value of 1.0. So we can tune the hyperparameter. From scikit-learn models, we use ridge regression cross validation. It will basically use a cross validation technique. So ridge regression cross validation, again you are using the pipeline and using the two steps, preprocessor and regressor. Here alpha is NP, we are taking values from -3 to 3 if we are checking on different values for 50 values from -3 to 3, and cross validation is equal to 5. So we are using 5 fold cross validation. And then a rich CV fit X train Y train, we are just fitting x train values with versus y train values, and then we will get the best alpha value, which uh, gives the best prediction. So alpha is now 25.5 far on this. So we again work with the model. We again set a rich regression pipeline with alpha is equal to 25, and then we can run. And this is x train, y train. We do all these steps again, and then we can check the mean square error. So the mean square error is again the same, almost 1774 and 42.12. So there is not much change in the values. So you need to make sure whether you have computed these performance measures from the latest values. Y test, this is the Y test, and the Y training, Y predicted. We get the Y predicted, and you are again using for mean squared error the Y test and Y predicted values. So there is not much change in the values, but for same accuracy and error, we need to set a value. Basically, mean square error is the combination of bias and variance. So we need to set alpha at 25 to get a trade-off between mean and an appropriate bias with a minimum variance. So this is the ridge regression. So ridge regression is used for uh, penalizing the uh, high dimensionality issue, when we have higher chance of high correlation between the variables. And again, in some cases, we have when we have large number of predictors, so we try to shrink the coefficients of those parameters to zero, which has no effect, which are redundant in our model. So in this way we can keep only appropriate set of variables in our model. So thank you so much for giving attention, and if you have any question, you can always comment in comment section. Thank you.